So we need the torque required to produce the acceleration. We know that omega initial equals 0 radians per second, and omega final equals 15 revolutions per minute. We know that this occurs in delta t equaling 10.0 seconds. And we know that we can say r is going to be the radius of the merry-go-round. The mass of the merry-go-round is going to be 560 kilograms. The mass of a child is going to be 25 kilograms. And again, here there are 2 children. So in order to find the torque, we know that the torque is going to be equal to the moments of inertia times alpha. This will be equal to the moments of inertia of the merry-go-round. We'll denote that as mgr, and then plus the children, I sub c, and times alpha. So delta omega divided by delta t. We know the torque is now going to be equal to, we can say 1/2 mr squared. This is the moment of inertia of a disk, or in this case, a merry-go-round, and then plus 2 children times mr squared. And so we can say this is going to be equal to omega final minus omega initial divided by t. And we know that omega initial is going to be 0. So in order to solve for tau, the torque, we can say that this is going to be equal to 1/2 times the 560 kilograms, the weight of the mass of the merry-go-round, times the radius of the merry-go-round, 2.5 meters squared, plus 2 children, 25 kilograms, the mass of the children, times 2.5 squared, and then this will be times 15 RPMs. We're going to have to multiply this by 2 pi radians for every 1 revolution, and then we can have to say 1 minute for every 60 seconds. And we are going to divide this entire thing by 10 seconds. And we find that the torque is going to be equal to 324 Newton meters. And we know that this equals the force times the radius. So if we wanted to find the force needed, we can say that this is going to be equal to the torque divided by the radius. So this will be 323.98 divided by the radius of 2.5. And we are getting a force equaling 129.6 newtons. So this will be our final answer. That is the end of the solution. Thank you for watching.